Hello guys, welcome back to my YouTube channel. So today we are going to solve day 23 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2471. Minimum number of operations to sort a binary tree by level. Okay, so let's read the problem statement first. You are given the root of a binary tree with the unique values. Okay, so all the values are unique. Alright. In one operation, you can choose any two nodes at the same level. Okay, and swap their values. Okay, so see these two nodes 4 and 3, they are at same level, right? So we can swap them, right? Return the minimum number of operations needed to make the values at each level sorted in a strictly increasing order. Okay, so see this keyword, strictly increasing order. Okay, so like this strictly increasing. Okay, so 3, after 3 we can have 4, after 4 we can have 5, after 5 we can have 7, 8. Okay, or something. Okay, value should be greater than the previous one. Okay, the level of a node is the number of edges along the path between it and the root node. Okay, so now let's understand this with example number 1. So this is nothing but my level 0. Okay, let's say this is my level 1. Okay, in level 1 we have 4 and 3. Okay, this is nothing but my level 2, and in level 2 we have 7, 6, 8 and 5. Okay, and this is nothing but my level 3. In level 3 we have 9 and 10. Okay, so here first see swap 4 and 3. Okay, the second level becomes 3, 4. So we are just going to swap these two nodes. Okay, so this node and this node we are swapping them. Okay, so that we can get strictly increasing order, right? So this is just one operation, right? I swap two nodes, okay, in one operation, 3 with 4 and 4 with 3. Okay, so this is one operation. Okay, now see this next level. So we have 7, 6, 8 and 5. Okay, so here I can change this 5 and 7, right? 5, 7 to 5 and 5 to 7. Okay, so this is one swap. So here what we get 5, 6 and 8 and 7. Okay, so we swap these two, right? This and this. Okay, so here at 7 5 5 is there, and at 5 7 is there, right? So now after that I swap these two. Okay, I swap these two. All right, so I will get 5, 6, 7 and 8. Okay, so see, this is one swap. Okay, this is second swap that I did, and this is a third swap I did. Okay, total. So here I will get in the end, this has 5, this has 6, and this is 7, and this is 8. Okay, and these two are already sorted, right? So how many swaps I am doing here? So first swap is between this and this. Okay, then the next swap is between this and this. Okay, so after that what I get here, I get 5 here and I get 7 here. Okay, and then after that I did the swap between this and this. Okay, so I get 7 here and I get 8 here. Okay, so total 3 swaps I'm doing, right? So this is what explained here, 7 and 5. The third level becomes 5, 6, 8, 7. Swap 8 and 7, the third level becomes 5, 6, 7, 8. Okay, we use 3 operations, so return 3. Okay, so it can be proven that 3 is the minimum number of operations needed. Okay, so I hope that you guys are clear with the problem statement. Okay, so in this problem, right, there is one hidden problem. That is nothing but you have one array. Okay, you have one array and you want minimum number of swaps so that our array becomes sorted. Okay, so this is one hidden problem inside this problem, right? Inside this complete problem there is one hidden problem to find the minimum number of swaps so that we can sort this array. Okay, so how we are going to do that? So see here, so this is my level, right? 7, 6, 8 and 5 we have, right? So now I have to find the minimum number of swaps to sort it. Okay, so here this 7 is at 0 index, this 6 is at 1 index, this 8 is at 2 index. Okay, and this 5 is at 3 index. Okay, so here I can create one map now. So in my map I am storing what 7 is at 0 index, 6 is at 1 index. Okay, 8 is at 2 index, and 5 is at 3 index. Okay, so this is nothing but my original array. Okay, now let's write my sorted array. Okay, if I sort this, then what I will get? So here I'm writing my sorted array. So in my sorted array, 5 will come first, right? And then 6 will come, then 7 will come, and then 8 will come. Okay, so in my sorted array, 5 is coming at 0 index, 6 is coming at 1 index, 7 is coming at 2 index, and 8 is coming at 3 index. Okay, so this is my original array and this is my sorted array. Okay, and for the original array I have created one map. Okay, and in the map I have stored the values and at which index they are. Okay, so my values as my keys and the indexes as the values. Okay, so this is what we need to do first. Okay, so now how we are going to do that? Okay, so first of all I'm going to, okay, I'm here, let's say my eye is at this position. Okay, let me use some other pencil. So let's say my eye is at this position. Okay, and here also my I is at 0 index, okay, at both of positions. So I'm going to compare this value with this value, okay. So both are not matching, okay. This value and this value are not matching, okay. So in my original array we have 7, but in my sorted array we have 5, okay. So both are not matching. So that simply means that we have to do one swap, okay. So here what I'm going to do, I'm going to increment the count of swap plus plus, okay. This is what I did. Now here in my map, okay, I will find out where 5 is located, okay. So this is what I need, okay. This 5 is what I need here, right? So what I'm going to do, I'm going to search this 5 in my map, okay, this 5 in my map, okay. So here I'm going to create one variable, let's say current position, okay, current position, okay. So let's say this is of int type, okay, int current position is equal to my map, okay. This is my map, okay. So let's say map name is pos, okay, position post dot get, okay. And here inside this I am searching for this value, okay, because this is what I need here in at this place, okay. So here I'm going to get write target at I index, okay. So this is what I need to write, right? So now from here what I will get, I will get post dot get 5, okay. So here 5 is at 3 index, okay. So here what I get that this value, okay, 5 that I'm searching is at 3 index, okay. So this is the current position of my this number, okay, current position of this number in my original array, right? 3. This is what I get here, right? Now what I'm going to do, I'm going to update my map, okay. So how I'm going to update my map, okay. So here I'm going to write pos, okay, my map, I'm going to update it pos dot put, okay, original of I, okay, this value, okay. So I am doing the swap now, I am doing the swap between this 5 and 7, right? 5 is coming at this 7, okay. Then definitely this 7 is going at 5 place, right, where 5 is there, right? So what I'm going to write, post dot put original of I, okay. This is nothing but my key and value as current position, okay, where pos, okay. So here post dot put original of I is 7, okay. At 7 I am adding the value as 3, okay. So here 7, okay, I'm going to update it to, I'm going to update this 0 with 3, okay. So this is what we need to do, right? So we are doing the swap now, right? 7 and 5 we are doing the swap, okay. Then definitely also I have to update my position of this value, okay. So 5 is coming at 0 now, okay. So this is what, so here I want to change it to 0, right? Okay. After this, so here I'm going to create one more, update my map here as well. So post output, okay, I'm changing the value of 5, okay. So that simply means that this value, okay. So this is nothing but my target, right? This sorted array is nothing but my target, okay. So here I'm just going to write target at I index, okay. This is sorted array, you can say target, okay. So target at I index, I'm going to update it with the original index, okay, I'm going to write. So here I have changed this 5 to 0, okay, and 7 to 3, okay. So this is one swap that I did, right? So here once I did this, then also let's update this original array as well, okay. So original array, in original array add this position, okay, at index 3, okay. Let's say pos, okay, at index 3 I'm just going to paste the original value, original of I, okay. So what I'm doing, original of I is 7, okay. So I'm just going to place this 7 at this position, okay. So here let me just erase it. So here I have updated, okay. So here 7 will come, okay, 7 will come here, right? And my I is going to move further, I is going to move further, okay. I is moving further, okay. My I reaches here, my I reaches here, okay. So this is already sorted, okay. That is why I'm not updating it to 5, but visually because I'm moving forward now, why I need to take care of previous one. But if you want, you can just for your for visual representation, you can say that this is my 5, okay. Now because it's already done now, I've already sorted, I have already incremented the count, okay. So instead of changing it in the code, I already know that I did swap here, okay. So now I'm moving further, okay, here in this part. So now this 6 is matching with this 6, okay. Nothing, no swap is required, okay. Now my I is moving further, I moves to this position, okay. I is moving here. So now I see there is one difference, okay. So I'm going to increment the swap count, okay. So this is the second swap that I'm doing, okay, in this level. All right. So now again what we need to do, okay. So first I'm going to search for this 7, okay. This is 7 what I'm looking for, and in my original array 7 is at index 3. Okay, so this is what I know. Okay, that is why I'm keeping track of. Okay, I'm searching for 7, and now in the direct operation I will get that 7 is at 3 index. Okay, that is why I'm using map. Okay, instead of searching it again in the complete array one by one, I have this. Okay, so at 3 we have 7. Okay, so what I'm going to do now after this, okay, so we know that 7 is at 3. All right, so I'm going to simply now update. Okay, I'm going to place this 7 at 2. Okay, and I'm going to swap this 8. Okay, so here I'm going to change it to 3. Okay, and then I'm just going to change it to 8. Okay, and for visual representation you can say that this is going to become my 7. Okay, then 8 and 8 is going to match. Okay, and then in the end that's it. Okay, so you are going to just return the count. Okay, that is nothing but 2 here. So simple operation that we are doing, right? So with the code you guys will get better understanding of this one. Okay, and since we are iterating level by level, right, so this is nothing but BFS. Okay, BFS, so we can implement queue. So in queue first I'm going to add 1. Okay, then I'm going to add the children of 1, 4 and 3, and then I'm going to sort this if possible. Okay, and count the number of swaps. Then for 4 and 3 I'm going to add the children, so 7, 6, 8 and 5. Okay, I am going to add the children. Okay, I'm going to remove these 2, and for this I'm going to do the sorting process. Okay, count the number of minimum swaps. So here I will get number of swap as 1. Okay, then for these 7, 6, 8, 5 I'm going to add the children, so I've added 9 and 10. Okay, then I'm just going to completely pull this out, and I'm going to calculate the number of swaps. Okay, so I'm going to write one helper method, okay, to count the number of swaps. So again it is going to give me, this helper method is going to give me 2. Okay, then I'm going to write the children for 9 and 10 and do the sorting here. Okay, minimum number of swaps. Okay, then I will get 0 here. Okay, 0. So total 1 here, 2 here, so 1 plus 2, 3. Okay, so now let's write the code for this one. Okay, so code is also going to be very simple. So we have to use queue, right? BFS. So here queue. Okay, and in queue what we are passing 3 nodes. Okay, queue is equal to new linked list. Okay, and in my queue I'm just going to add a root. All right, and now we have to calculate total swaps. So I'm creating one variable, total swaps is equal to 0. All right, and then we have to process the tree level by level using BFS. So here I'm going to run one while loop while my queue is not empty. Okay, now here inside this we are going to calculate the level size. Okay, level size is equal to queue dot size. Okay, so this size is what I'm going to sort, right? Queue dot size. So initially there is just one node, right, and creating one array as well, level values new int, and here I'm just going to pass level size. So currently there is just one node, right, so 1 is the size. Okay, now I'm just going to iterate over all the nodes that I have, okay, until now, and I'm going to add the children. Okay, I is less than level size I plus plus. All right, so tree node is equal to queue dot poll. Okay, and here level values, okay, at I index, okay, which is 0. So here I'm just going to pass that node dot val. Okay, so this is done. Now we have extracted this 3 in the starting. Okay, so in the starting we have just uh, this 1. Okay, in starting we have just 1. Okay, node 3, 1 is there, so I have extracted this one. Okay, for the first level 0. Okay, so and I'm also going to add the children of this one, 4 and 3. So here what I'm going to write, if this node, okay, 1, that is 1. Okay, for this example node dot left is not equal to null. All right, so here what I'm going to do, queue dot add node dot left. Okay, and if node dot right is not equal to null, then in that case queue dot add node dot right. Okay, this is done. So basic things that we have to do. Okay, and once this is done, okay, so I have to I've added the children and everything here. Okay, and now just check the total swaps that I did. Okay, total swaps. So for this I'm just going to call this total swaps is equal to total swaps plus I'm going to call this method get min swaps. Okay, and in this I'm just going to pass my current array. Okay, level values. Okay, and here I'm just going to return swaps. That's it, return total swaps. All right, now let's write the code for this get min swaps. Okay, so this is one thing. Now we have to calculate the minimum number of swaps needed to sort an array. So it's very simple. Private int get min swaps, and here int original, okay, array, and inside this for the current level, okay, swaps 0 right now, and I'm going to create one target array, okay, or you can say sorted array. So here it's nothing but just cloning the original one, original dot clone, copying the same array, and then I'm going to sort this arrays dot sort this target. Okay, so I have sorted this. Now for the original array, I told you that we have to create one map, okay, containing key and value pairs, both are of same type, integer, 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 okay, and name it as pos new, and here hash map, okay, then just iterate over my original array int I is equal to 0, I is less than original dot length I plus plus, okay, and what I need to do, I need to put all this in my map, okay, post dot put, okay, so original of I, that is nothing but my particular number, and add bit index that I have. Okay, so I have created one map like this. All right, and then again iterate over my array for int I is equal to 0, I is less than original dot length I plus plus. All right, and here inside this simple thing that I have to, if original of I, if it is not equal to target of I, okay, then in that case we have to increment the count of swaps, okay, and same things that I have mentioned here. Now I'm going to write the same thing, current rows, okay, all these lines. So here int cur pos is equal to pos dot get target of I, okay, and then pos dot put, okay, and here original of I cur pos, okay, and pos dot put target of I as I, okay, and here original of cur pos is equal to original of I, okay, so that's it, and here we have to just return swaps. Okay, now let's run it and see if there any code issue. So yes, so here let's correct that. So here purpose, okay, let's run it again. So the test cases has been accepted. Right now let's submit it. Okay, so see our solution is accepted, right? And here if you see carefully, here 7 initially, here if you see here 7 was there and 5 was there, so I was just modifying this, right? 7 was there and 5 was there. Okay, so here I just modified this 7 and I didn't change it to I just remain it as 7 only. Okay, that didn't change it to 5. Okay, because why? Because we are moving forward. Okay, why we need to care about previous indexes? Okay, so right, this is clear, right? We are moving forward only, so why we need to care about whether we put 5 here? We have already incremented the count now. That's what we need. Okay, that means that we have changed it. Okay, same way there is also actually no need to change the index of this one. Okay, here I'm placing 5 now, so 5 is at 0, so there is no need to update this as well. Okay, because we are already moving forward. In forward there is no element 5, so why we are changing it 5? Okay, here I'm in the map, I'm changing 5 to 0, right, in the map, but since we are moving forward only, there is no use of this 5 later on in our stage. Okay, so right now our solution is accepted. Okay, but if you want, you can also remove this line. There is no need for this one. Okay, so if I just comment it out and just submit it, okay, so then also my solution will be accepted. Okay, because there is no change. Okay, because there is no requirement of updating this previous value. Okay, the key value pair for this one. Okay, there is no need because we are not using 5 later on. Okay, so you can ignore this line if you don't want to add, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.